All right, to finish up chapter 14, we are going to be talking about solution stoichiometry. So, with stoichiometry, we are using a balanced chemical equation in order to solve these. So, we have to go from one substance to another substance, which means we are using our balanced chemical equation, our coefficients in our balanced chemical equation, to jump from moles of one substance to moles of another substance. So that's the only way we can switch substances is through moles. So these problems are typically a little bit longer, and they require a balanced chemical equation to solve these problems. So we absolutely need a balanced chemical equation. Okay, so let's read example number 10. Given that 37.5 milliliters of 0.10 molar aluminum bromide solution reacts with a silver nitrate solution, what is the mass of silver bromide produced? And we're given the molar mass of silver bromide. So notice I have underlined, we're starting with aluminum bromide, and we are jumping to silver bromide. We want to know something about another substance, which means we need a balanced chemical equation because we're going to another substance. We're going through moles. So we know everything that we need about aluminum bromide. We're trying to find something about silver bromide, so we're holding off anything with silver bromide until later, especially towards the end. So of these two numbers, milliliters and molarity, we're going to be starting with our single unit. So we're going to start with milliliters, this 37.5 milliliters. So we're starting with 37.5 milliliters of aluminum bromide, and we're given our balanced chemical equation. So milliliters, we need to convert to liters, so we're going to use these conversions that we have here. So milliliters goes on the bottom, and we're going to liters up top. So again, you can use either of these, totally fine. So once we're in liters, we're going to convert to moles. And we can do that because we're given the molarity of our aluminum bromide. So again, molarity is moles over liters. So that's 0.10 moles in 1 liter of aluminum bromide solution. So now that we're in moles of aluminum bromide, we can jump to another substance, doing a mole to mole conversion using our balanced chemical equation. So moles of aluminum bromide are going on the bottom. So that those cancel out, and we got moles of silver bromide up top. Once we're in moles of silver bromide, we can figure out the mass of our silver bromide by doing a gram to mole conversion using our molar mass. So grams per mole, molar mass. So moles of silver bromide has to go on the bottom. We got grams up top. Remember, the number 1 always goes with the bottom unit. So grams over mole, moles is on the bottom. We put the 1 there. Okay, so we're going to put this into our calculator. So it looks like we have 1s all on the bottom, so we're just multiplying everything up top. And with 3 sig figs, we get 2.11 grams of silver bromide. So it's a pretty long process, and we need a balanced chemical equation for these guys. Okay, let's look at example number 11. With example number 11, it says, given that 27.5 milliliters of 0.210 molar lithium iodide solution reacts with 0.133 molar lead-2 nitrate solution, what volume of lead-2 nitrate solution is required for complete precipitation? So let's think about our units. So we know everything for lithium iodide. So we're given milliliters, moles, molarity, concentration of lithium iodide. We know the molarity of our lead-2 nitrate, and we want to know volume of lead-2 nitrate. So basically how we're going to do this is we are converting milliliters to liters. At that point, we can go milliliters to moles. Here we can go moles of one substance to moles of another, so moles of lithium iodide to moles of lead-2 nitrate. Once we're in moles of lead-2 nitrate, we're going to use our molarity to convert to liters because we want to know volume. Okay, so let's look at what we have here. So we're going to start with our single unit. So that's the 27.5 milliliters of lithium iodide. We need to convert liters, to liters so that we can use this molarity number. So that is 1 milliliter is equal to 10 to the negative third liters. Again, you can use these guys, just make sure you're canceling units. Okay, so once we're in liters, we get to use our molarity for our lithium iodide to get to moles. And once we're in moles, we get to convert a mole-to-mole conversion and jump over to lead-2 nitrate. So moles of lithium iodide are canceling on the bottom. We want moles of lead-2 nitrate. Once we have moles of lead-2 nitrate, we need to convert to liters of lead-2 nitrate. And we are gonna put our molarity so that moles cancels on the bottom with here, and we're ending up with liters up top. We want our final unit to be up top in our numerator. So for lead-2 nitrate, where did I write that? Oh, down here. So our problem just asks for volume. So in case like your homework specifies exactly what it wants, I put it in liters and milliliters. So just moving the decimal place over 3. So we get 0.0217 liters or 21.7 milliliters. All depends on what your homework asks you for. So at this point, you can do the solution stoichiometry worksheet.